When a star like our Sun begins to die, it expands into a bloated red giant star, shedding mass by puffing off its outer layers. This change alters the gravitational influence the star has on its planetary system. The gravity of the remaining large planets can disrupt the orbits of small objects like asteroids, comets, and moons, scattering them like pinballs in an arcade game into exaggerated oval orbits. As the red giant star runs out of its nuclear fuel, it begins to contract, creating a compact white dwarf star no larger than Earth. The exaggerated orbits of the wayward objects may bring them very close to the star, where they experience powerful tidal forces that tear them apart, creating a gas and dust disk around the white dwarf that eventually falls onto the star's surface. 5 billion years from now, when our Sun is at the end of its life, Mercury, Venus, and Earth will likely be completely vaporized as the Sun becomes a red giant. The orbits of asteroids in the main asteroid belt will be altered, eventually falling onto the white dwarf that our Sun will become. This scenario is exactly what is happening to a nearby white dwarf star named G23844. The star's death throes have so violently disrupted its planetary system that it is actively siphoning off debris from both the system's inner and outer reaches. Using archival data from Hubble and other NASA space observatories, astronomers have for the first time observed a white dwarf star consuming both rocky metallic and icy material. The findings are intriguing because icy bodies are credited with irrigating dry, rocky planets. Billions of years ago, comets and asteroids are thought to have hit our planet, delivering water, and sparking the conditions necessary for life as we know it. The makeup of the bodies raining onto the white dwarf implies that icy reservoirs might be common among planetary systems. This white dwarf provides a unique opportunity to take distant planets apart and see what they were made of when they were first formed around the star, letting us better understand what makes up star systems besides our own.